Last video we introduced Gulf Stream and we talk about the history briefly, and we're going to move to Arctic Ocean. The Arctic Ocean is a unique water body that covers a little over 40 million square kilometers. It's almost surrounded by land masses North America, Greenland, and Eurasia, and is totally covered by sea ice in winter. It is the shallowest of the world's ocean and receives about 4,200 square kilometers of freshwater discharge annually, about 60% from northern Asia. As a result, its surface salinity is only about 33%, and its surface temperature averages about -1.7 degrees Celsius, close to the freezing point of seawater. Below about 50 meters depth, the temperature and salinity both increase. The warmer, more saline Atlantic enters the Arctic Ocean via the Norwegian and the Barents Seas at immediate depth, 200 to 900 meters. In the Beaufort Sea, north of Alaska and southwest Canada, there is a large clockwise gyre that is driven by a quasi-permanent high-pressure center in the winter half-year. From Siberia to the French Strait of East Greenland, there is a transpolar drift stream that transports sea ice out of the Arctic Ocean into the Greenland Sea. The Arctic Ocean begins to freeze in October, and sea ice becomes continuous over the Arctic Ocean and the waters of the Canadian Arctic and archipelago. It extends into Baffin Bay, the Labrador Sea, Hudson Bay, the Barents Sea, the Bering Sea, and the Sea of Okhotsk, with a total area of around 50 million square kilometers in late winter. There is also sea ice in Bohai Bay of eastern China at latitudes 38 to 40 degrees north. Young ice is highly saline because sea salts are trapped in the ice. But during the winter, brine drains out into the ocean, making ice that is low in salinity along the coasts of the Lapu Tibet and East Siberian seas. In the Canadian Arctic archipelago, winds may drive ice away from the land, forming areas of open water and a thin young ice known as polynes, a Russian term. These polynes are major sources of heat fluxes so the atmosphere, and are also vital habitat for many marine mammals. In the cold Arctic winter, polynes tend to rapidly freeze over. The winter ice has a snow cover that is about 30 to 40 centimeters deep. In summer, the snow melts, forming meltwater ponds on the ice, which in turn melts and thins. Much of Europe's history, the North Polar region remained largely unexplored, and their geography conjunctural primary recorded an account of a journey northward in 325 BC to a land is called Istutub, where the sun only sets for 3 hours each day and the water was replaced by a concealed substance on which one can either walk nor sail. He was probably describing lost sea ice known as today's glowers or burger beets. This tooling was probably Norway through the France island or Shetland were also being struggled. Early cartographers were unsure whether to draw the region around the North Pole as land or water the fervent desire of European merchants for a northern passage. The Northern Sea route of the Northwest Passage or Cathay China caused water to win out, and by 1723, map makers such as Jordan Holman featured an existence oceanist Stephanie Niles at the northern edge of their chart. A few expeditions penetrate much beyond the Arctic Circle. This era added only small islands such as Nova Zers and Spitsbergen. Though since these were often surrounded by pack ice, their northern limits were not so clear. The maker of navigational charts more conservative than some of the more fanciful cartographers tended to leave the region blank with only fragments of known coastline sketched in. This lack of knowledge of that lay north of the shifting barrier of ice gave rise to a number of conjectures. In England and other European nations, the myth of an open polar sea was persistent. John Barrow, longtime Second Secretary of the British Admiralty, promoted exploration of the region from 1818 to 1845 in search of this. In the United States, in the 1950s and in the 1850s and 1860s, the explorer Elisha Kane and Isaac Israel Hayes both claimed to have seen part of this elusive body of water. Even quite late in the century, the eminent authority Matthew Fulton Ferry included a description of the open polar sea in his textbooks, The Pacific Geography of the Sea, in 1983. Nevertheless, as all the explorers who traveled closer and closer to the pole reported, the polar ice cap is quite thick and persists year-round. So, Fridtjof Nansen was the first to make a nautical crossing the Arctic Ocean in 1896. The first surface crossing of the ocean was led by Wally Herbert in 1969. In a dog sleigh expedition from Alaska to Svalbard with air support, the first nautical transit of the North Pole was made in 1958 by the submarine USS Noctinals, and the first surface nocturnal transit occurred in 1977 by the icebreaker NS Arctica. Since 1937, Soviet and Russia manned drifting ice stations have extensively monitored the Arctic Ocean. Scientific settlers were established on the drifting ice and carried thousands of kilometers by ice floes. In World War II, the European region of the Arctic Ocean was heavily contested. The Allied commitment to resupply the Soviet Union via its northern ports was opposed by German naval and air forces. So from 1979 to mid-1990s, the summer minimum in September averaged about 6.5 million square kilometers, but there was only a long-term downward trend that accelerated in the 2000s. The winter trend in ice area was negative 3% per decade, and the summer trend negative 12% per decade up to 2011. Between 2007 and 2011, the summer minimum averaged only 4 to 5 million square kilometers. In September 2012, a record minimum of 3.4 million square kilometers was recorded. Moreover, the ice thinned dramatically between the 1970s and the 2000s, from 3.1 million to about 3.1 meter to about 1.5 meter, and the proportion of old multilayer ice dropped sharply. In the 1950s to 80s, there was typically 40% first-year ice and 60% older ice in the late 1990s to 2000s. These percentages reversed as much old ice was reported out of the Arctic Ocean. Two other factors that account for the thinning and ice retreat are incursions of warm southerly airflow over the Arctic basin and the advection of warm water from the North Pacific Ocean via the Bering Strait into the Chukchi and Persford seas. Southern Hemisphere currents. So in the Southern Hemisphere, there were broad anticyclonic gyres in the three oceans that features cold northward flowing currents of Southwest Africa, the Bengal current of Western South America and the Humboldt or Peruvian of Western Australia, the leewarding and the eastward flowing equatorial currents in each ocean. On the western boundaries of the oceans, there are warm southward flowing currents, the Angluhas or Mozambique of East Africa, the Brazil current of Brazil and Argentina, and the East Australia current. To the south, there is a broad eastward flowing Antarctica circumpolar current that is continuous around the hemisphere. It's up to 2,000 kilometers wide and 2,000 to 4,000 meters deep, with speeds of 20 to 40 centimeters per second. It transports an enormous amount of water, of the order of 125 CV. The ACC keeps warm ocean waters away from Antarctica, enabling the continent to maintain its enormous ice sheets. Sea surface temperatures decrease from about 5 degrees Celsius at 55 degrees Celsius in the Drake Passage, south of South American, to 0 degrees Celsius at 60 degrees Celsius south. Sea surface temperatures in the eastern South Pacific display cold water related to the Peru current and cold upwind caused by the offshore winds along the tropical west coast of South America. The cold water turns westward in a narrow current along the equator. In the western equatorial Pacific of New Guinea, there is a warm pole with surface temperatures above 29 degrees Celsius. The warm pole is an important locus of convection and plays a role in tropical cyclone development. The Southern Ocean. The waters in the Southern Ocean of Antarctica have extensive sea in winter, covering about 20 million square kilometers at maximum in September. The ice averages about 0.9 meters in thickness with a deep snow cover. In the growth phase, the height of snow depresses the ice flows, allowing seawater to flood the ice and soak the snow. This then freezes into snow ice, a process that is absent in the Arctic. By late summer March, the sea ice has gradually retreated, with about 3 million square kilometers remaining. Mainly the Weddell Sea close to the coast of Antarctica, there is extensive land-fast ice attached to the land that can glow thermodynamically by heat conductive losses to 2 meters in thickness during the winter season. The southern oceans are colder than their northern counterparts due to the presence of Antarctica in the Southern Ocean, which is much colder in the austral summer than the Arctic in the boreal summer. As a consequence, the location of the thermal equator and the ITCZ between the two trade wind systems are displaced northward from the geographical equator to around 5 degrees north. The westerly winds in the Southern Ocean are uninterrupted by